Hello and welcome to today's lesson. Today we are going to look at a Kcse question, that is Miranda post-mock exam under longitudes and latitudes. But before we look at this question, if you have just come across this channel for the first time, kindly subscribe to the channel. Let us go through the question together. An aeroplane leaves point A 40 degrees north, 78 degrees west, and flies due west at 900 kilometers per hour. If it travels for 3 hours 20 minutes, taking the radius of the earth as 6370 kilometers, how far has it traveled? How far in this case is referring to distance. And we know we have been given the speed of the aircraft, and the speed of the aircraft is 900 kilometers per hour. We have also been given the time, and the time has been given as 3 hours 20 minutes. 3 hours 20 minutes is the same as we have 3 hours 20 minutes, that is like 20 out of 60 into hours. 0 and 0 goes, so that we remain with 2 over 6. 2 goes to itself once it goes to 6 3 times. So time is actually 3 hours and a third. 3 and a third hours, which it translates to, that is as an improper fraction, it is 3 times 3, which is 9. 9 plus 1 will give us 10, which is 10 over 3 hours. This is the same as 10 over 3 hours. How far is referring to distance, and we know distance is always given by speed times time, and we already know that our speed is 900 kilometers per hour. We multiply by the time, which is 10 over 3. 3 goes to itself once it goes to 900 300 times. So if you take 300, you multiply by 10, this one is going to give us 3000 kilometers, and that is how far this aeroplane has traveled. Going to part B of the question, what is the longitude of its position? We have been told that the aircraft left point A, which is 40 degrees north, 78 degrees west, and flies due west. It goes straight to the west. It means if it is going due west, it is moving straight, maintaining the latitude at 40 degrees north, but we do not know the new longitude position. Let us call it X. If you look at what the 2 points have in common, it is that it is moving along a small circle since they are sharing the latitude. And if it's moving along a small circle, we can get the distance, and we know distance along a small circle in kilometers is given by the longitude difference. You divide by 360 times 2 pi r, then cos the latitude position. We talk about cos the latitude position. In this case, we can say our longitude difference be equal to theta over 360 times 2 times pi, which is 22 over 7, times r, which is 6370, and this then cos the latitude. The 2 points are raised 40 degrees north, so the latitude position is 40 degrees, and this must be equal to the distance covered, and the distance covered is 3000 kilometers. So if we multiply the upper part, we are going to have 22 times or we can begin with cos 40. We have the cos of 40. We multiply by cos 40, we multiply by 6370. We multiply by 22. We multiply once again by 2. Then we divide by 360. You multiply by 7. It gives us 2520. So we divide by 2520. And this one is going to give us 85. This one is going to give us 85.20 times theta, which gives us 85.20 theta, and this must be equal to 3000. So if you want to get our theta here, we are going to take 85.20, we divide by 85.20. 85.20 and 85.20 cancels, so that we get our theta here, and our theta is going to be equal to 3000. You divide by the answer, and this one is going to give us 35.21 degrees. So our theta is going to be equal to 35.21 degrees. From here we can say that if we can draw or sketch our diagram here, this is the prime meridian at 0 degrees. Assuming this is our point A, which is 40 degrees north and 78 degrees, that is 40 degrees north, 78 degrees west, and this aeroplane is flying due west, meaning if it's going still to land at 40 degrees north, the longitude is going to be different. Since from 0 going to the west is 180 degrees, so for us to get the longitude position of the next point, which is x, we are going to take 78, we add the degree difference displacement towards the west. So the longitude position, in this case, the longitude position is going to be equal to, we take 78.0 degrees, then of course we add the displacement angle of 35.21, and this one is going to give us, we add 78, and this one is going to give us 113.21 degrees, 113.21 degrees, and that is the answer to that question. Thank you for watching and welcome to our channel.